Next on my list is what I refer to as the comparison test. So imagine here's a series involving the A sub n that I'm trying to determine convergence or divergence for. And I'm going to compare it to another series with which I'm familiar. It's typically going to be a geometric series or a p-series. Now, if my nth term is less than or equal to the nth term of another series that converges, I forgot to write that, but this converges, then my series converges as well. But if my nth term is at least as big as the nth term of a series that diverges, then my series diverges as well by the comparison test. Now, be a little careful. If my nth term is at least as big as the nth term of a series that converges, there's no conclusion. If my nth term is at least as big as the nth term of a series that diverges, no conclusion. I hope those are rather obvious. So let me try to use a comparison test to ascertain whether or not this series converges or diverges. Now remember, lowercase n is just a natural number. Let's see if I can't compare these two. I think I can. Because these two fractions have the same numerator. But this denominator is larger than that one, so this fraction is going to be less than this fraction for all natural numbers n. And now let's see what the comparison test tells us. Well, notice how this is the nth term of the harmonic series, which we know diverges. But because my nth term is less than the nth term of a series that diverges, the comparison test has no conclusion. It only says something if my nth term is less than the nth term of another series that converges, or if my nth term is greater than or greater than equal to the nth term of a series that I know diverges. So when my nth term is less than, in this case, or in general, less than or equal to the nth term of a series that's known to diverge, then the comparison test doesn't give me a conclusion. But that's okay. I can change this. What if I compare my nth term to the nth term of this series? Is this fraction nothing more than this? And that's the nth term of a geometric series, where r is equal to this fraction, which is strictly less than 1 in absolute values. So this is the nth term of a series that converges. And since my nth term is less than, or in general, less than or equal to its nth term, then my series converges as well by the comparison test. I need to see that in writing. So let me show you what I need to see. I need to see this. I need to see that. Maybe different words, but I need to see the conclusion as well.